Can't believe we're here. MSM3, first lesson of the year, and it is one that you are going to rock. We're talking about adding and subtracting integers, which we've done before. Just going to reintroduce some concepts to make sure that things are fresh. So here we go. Integers, what are they? Positive and negative whole numbers, including zero. So no decimals, no fractions. The set of integers looks like this. So we've got -3 up through 3, but you'll notice the 3 dots on the ends. Those mean that the list goes on forever. These 3 dots mean the same thing as this arrowhead, goes on forever. So integers are often represented by using a number line as shown below. We can't write them all, so we use the arrowheads to show that it would go on forever. There's also an arrowhead on this side as well for the same reason. On the number line, the numbers get larger as you move to the right, hence smaller as you move to the left. So you'll notice that all the negative numbers are to the left of 0, and all the positive numbers are to the right of 0, getting bigger. Absolute value, the distance a number is from 0. So distance, if you've ever watched Ferris Bueller's Day Off, remember how putting the car in reverse did not take off miles? Well, that's because it doesn't matter what direction you're going. Distance is always positive. So absolute value is always positive. All right. Add that note right in there. So what we've got below that are some equations, and I know they're equations because they have an equal sign. And this one says, what is the absolute value of 5? And then it's equal to the number 5. So it's really important that we know how to read this. So this, with the 2 vertical bars on either side of the number 5, says, what is the absolute value of 5? And it's a question. And then we're saying it's equal to, and the answer is 5, or 5 units from 0. So if we look up here and we're like, well, what's the absolute value of 5? It's 1, 2, 3, 4, 5 units away from 0. Don't care whether it's left or right. I'm just talking about distance. So absolute value of 168, what is the distance from the number 168 to 0? It is 168 units from 0. What's the absolute value of -7? Well, because it doesn't matter what direction we're going, we're just saying how far is the number -7 from 0? It would be over here, right? It would be a little bit further away, and we would say it is 1, 2, 3, 4, 5, 6, 7 units away from 0. So the absolute value of -7 is equal to 7. Same idea, except we'd be way further down the number line, and no one wants to count 103 little hops. So the absolute value of -103 is equal to 103 units from 0. And 0, how far away is 0 from 0? None. So 0, absolute value of is 0. 2 numbers are opposites if they have the same absolute value but different signs. So opposites, not the same thing as absolute value. So what we might want to do is highlight vocabulary words so that we can find them easily later if they're not already visible enough. So opposites have the same absolute value but different signs. So that's really important. So a number like 5 and -5, those 2 numbers are opposites. They're both 5 units away from 0, but they have different signs. Also, you'll notice it says the sum of 2 opposites will always be 0. So 8 and -8, they're both 8 away from 0, and they add up to 0. -58 and 58. So you could also check and say -58 plus 58 equals 0. They have a sum of 0. They're the same distance away from 0, but one is negative and one is positive. So what if we want to add integers like we just looked at here? If they're both positive, you simply add them like you always have. So 2 plus 7 is 5. No, that doesn't make sense at all, does it? No. 2 plus 7 is, yes, you have to make sure that you're keeping track of what I'm asking you to do. 2 plus 7 equals 9. So when I take a look at your notes, I should see that you've made that correction because there was a mistake on the notes. You should not have mistakes if I correct them in the video. And then we've got 19 plus 41 equals 60. Both negative integers. Add the numbers. The answer will be negative. Okay, that makes sense. -5 plus -7, I'm adding together 2 negatives. Altogether, I have 12 negatives. Similarly, if you owed your brother $5 and you owed your sister $7, right? You're at -5 and -7. All together, right, addition, we would owe our siblings $12 or we'd be at negative 12. So we can add two negatives and we just get a negative answer. What if we're adding integers where one is positive and one is negative? Different signs. So first, if they're opposites, we know that adds up to 0 because we have 58 negatives and 58 positives. That comes out to 0. But what if they're not opposites? So negative 6 plus 9. Find the difference of the two numbers ignoring the sign. So the first thing we want to do is say, what is the difference between 9 and 6? We would get 3. And then we would want to say, are there more negatives or more positives? 9 was the larger number, so we had more positives. So the answer would be a positive 3. And notice I don't need to put a plus sign because if there is no sign, we know that means positive. We also have 5 plus negative 12 equals negative 7. So 5 and 12, what's the difference? The difference between 5 and 12 is 7. 12 take away 5 is 7. And which did we have more of? We had more negatives this time. We had 12 negatives compared to the 5 positives. So this is a negative 7. We had more negatives than positives. So I can do the same thing. This is called rewriting sometimes as well. But in this case, we would have to make sure that we clarify, like, this is our final answer. That's why it goes up here. The difference between 12 and 5 is 7, but our final answer is negative 7. 16 and 4, the difference is 12. But since I had more negatives, negative 16, that would make the answer negative 12, and that would be my final answer. 17 and negative 7, the difference between 17 and 7 is 10, and I had more positives, so the answer is simply positive 10, final answer. And negative 17 plus 38. Now, this one might not come as quickly, right? You might have to do 38, take away 17. You might have to think about 38, take away 17 this way. Either way, the difference is 21, and you'd have to look and say, well, I had more positives than I did negatives, so the final answer is positive 21. So that's not too bad. Then we also are going to look at the back. We're going to look at subtracting integers. And since we're really good at adding integers, we're going to focus on that strength and say, okay, in order to subtract integers, we are going to add the opposite. We're going to change all of our subtraction problems to addition problems. So we are going to, for every single subtraction problem, we're going to rewrite the subtraction as addition. First thing, rewrite the equivalent addition problem, then solve. So how do we do that? The first number in the problem never changes. Well, that's great. That's one thing I don't have to do. Change the subtraction symbol to addition. Well, that makes sense since we are rewriting subtraction as addition. And change the second number to its opposite. That sounds like the thing that's going to get me sort of like potentially hung up. So change subtraction to addition and change the second number to its opposite. First number stays the same. Great. So let's say I had something like 17 take away 4. If I were going to follow these rules, yes, I know the answer is 13. Yes, I know you can do that in your head. But if I were going to do this, I would say 17 stays the same, change subtraction to addition, and the second number becomes its opposite. So those two expressions are equivalent. They're worth the same. This one is 13, which means this one is also worth 13. 17 take away 4 is 13, more positives than negatives. What if it were 20 take away negative 3? So the 20 would stay the same, the subtraction would become addition, and the negative 3 would become a positive 3. I don't know why I wrote 4. The 20 plus positive 3 would be worth 23. 20 take away negative 3, also worth 23. Those are equivalent expressions, so they have the same answer. So what you'll notice down here is that every one of these started as a subtraction problem. We changed it to addition, and we changed the second number to its opposite. So the 9 didn't change. Minus became a plus. 3 became a negative 3. So same change, change. Sometimes people do that to remember. But these are all examples of the same type of problem that I just did above. Now, your video check-in. What do I need you guys to do? Grab a piece of paper, grab an index card, something. You're going to look at these two questions. Here we go. So question number 1, what does, this is a 6 inside 2 vertical bars, look like in words? So I want you to write out in words, like I did on the front of the notes, how this would look in words or how you would say it in words. Question 2, rewrite negative 3 minus negative 2. Then find the final answer. All right, I will see everyone in class.